All right, what are we doing today? Today we are going to, right now we're working on moving the logic from the client so it can be used by the client and the server. Let's look at what we have to do. We have a bunch of render specific stuff, file loading up here in the client. We load everything in, we create a new engine, then we create a tile map. This is our tile map data structure. So it should be common across the client and server. Let me open up our MMO.go. This is kind of like all of our gameplay logic as we have it now. So I guess we'll have a function up here. We'll just load the entire game. And part of that loading is the tile map. We have tile sprites. This is client specific. Client specific. Then we create all of our people, of which there's only 2. Actually, we only want the spawn point. Let's just copy the spawn point. This is where we're going to spawn our people at. This is the position in world space where we'll spawn our people, rather. Then we need to create our people. So most of these components are shared in the client and server. But I guess what we'll end up doing eventually is we'll be spawning them on the server, sending data to the client, and then because the data was received on the client, we'll spawn them as well. So the client will be the server will be the authority on who is where and what they are. And then the client needs to interpret that. We can create our people here. So sprite is more of a client-specific thing. Spawn point, however, is defined by the server. Then they have like a physics input, which controls which direction they're going. That's basically their like, are they pressing up, down, left, or right, or what arrow keys are they pressing? What's the user input? But abstracted away from the like renderer, because the renderer cares about keybinds. All the rendering stuff we'll leave here for now. We'll comment it out. We'll just spawn them and define their input component. And they have their sprites, which I guess isn't useful right now. We'll have to put that into a system, which will basically interpret what what their, I guess, body type is, and then it'll assign the right sprite based off of their body type. Camera is very client specific. Then we had to define our input systems. The physics systems are common for client and server. Then we have some rendering systems. So that looks generally fine. So we're kind of moving the game, all of the game logic to the server now. But we'll have this return 3 things. We'll have this function return 3 things. We'll return the tile map. We'll return the man ID and hat man ID. And that's just for convenience. Eventually, like, we can't do that, but we'll just use that so that we can do keep our client drawing and stuff. Oops. I'm gonna pass the engine in here. And I think that's it. Also, we don't want to seed off of time because we don't want a randomly generated world. Let's just pick like 1, 2, 3, 4, 5. It'll be our world forever. We'll make the map size slightly smaller too. Cool. We'll pass the engine, the ECS engine in. And that's it, I think, actually. Now we can also do, we can uncomment this because we'll have access to hatman ID and man ID. So I think that's a good start. Let me open up a terminal to start our server. Oops. Launch our server, which actually isn't loading the game yet, so maybe it should be doing that. Yeah, let's, we'll run it. We can start our client. Some errors. Oh, I am literally in the MMO package. Seed. Oh, this should be an N64, I believe. And then we didn't specify our return types. And then we'll do return an ECS.id, ECS.id. This will be our group of return values. And find load game. Forgot to scope it. All right, there's our little world and our people. Cool. And I'll slowly switch over to the server. And right before we launch our WebSocket server, we will load the game. So then the data is kind of copied to both. MMO.go, load game. We'll create our engine. I can't actually remember what we did for the client. We just copy that. And actually, we don't actually need any of these things, do we? Not yet, at least. But eventually those would represent like the tile map and the players, and that would be data when you would need to send from the server to the client, or from the server to replicate on the client. So, all right, let's relaunch our server. Some ECS, MMO. Oh yeah. I literally haven't imported anything from our project. Actually, we need MMO, and then we need the ECS package as well. Conversion ECS engine. Is it new engine? There we go. Okay. So now we're loading the tile map and spawning the people, but we're not actually running any systems on the server yet. So the only system we need is our physics systems, because we don't care about the input systems, nor do we care about the rendering systems on the server. And I'm messing my typing up today. All right. So this will spawn our physics systems where there's just one, which takes the input and then converts it into like movement, basically modifying the transforms X or Y value depending on which direction was being pressed. So that can be run on the server, but we need to launch it now. We were doing this run game. So we'll put that in the Go routine. And that will run, because this literally just runs until until this quit signal gets specified, which is kind of this like thread safe bool basically. So that will run until quit gets specified. So that'll run basically forever. But we do need to create that quit signal. So we will create quit. We'll start our ECS system list, which is created here. Then we can launch our server. And then after our server shuts down, I guess our server will wait until either the server will wait until it gets closed, and then I guess after it's closed, we can we'll shut down the server, and then after we shut down the server, we can shut down our we can stop running our game loop. Is that good? Yeah, I guess we'll just do this. We'll just do quit.set true. That'll basically indicate that our go routine needs to stop. I guess that technically what will happen is the function is just going to exit though. We'll do this actually. We'll stop a little bit earlier. Right before we start shutting down our server, our WebSocket server, then we will set quit to true so that the for loop can exit. That this for loop up here, or actually it's at the wrong spot. This for loop will exit. And this just runs through all of our systems. Input first, then it goes to our physics systems, and then it goes to our render systems. And it tracks the frame time. Eventually we'll have to have a fixed time step, but I haven't implemented that yet. We'll do that later though. For now it goes as fast as it can. Maybe I should have it sleep. No, that's fine. Okay. Now, systems should run. Let's start our server. Oops. Create physics systems isn't there. Input physics render. Oh yeah, so the physics doesn't have input systems, nor does it have render systems. So we'll just do, actually, can we just do nil? No, we'll just do an empty one. ECS.system. We'll pass an empty input and render systems because we don't care about those. Everything needs to happen on a server physics tick. I guess we could make a different loop, but we'll do that for now. It's a little bit hacky, I guess. Let me start this again. Physics systems. Physics systems. We're missing S there. Classic typo. Okay, now it's running, and presumably our systems are going to. But they're not communicating yet, so that'll be the next thing we have to do. I guess that might be good enough for now, though. Let's look at what's in the client still, because our goal originally was to move all of the common game logic out of the client into packages. You have network stuff, and then basically you have this load game, which runs and creates everything. Then you have rendering setups. Then we create some people, and eventually this will need to system that converts body type into sprites. Because the server doesn't need any knowledge on what sprites are actually being rendered. So we will exclude that from server logic. Then we set up the different keybinds. Eventually we'll just have one player owns one like server instance of a player. Then more render stuff. Then we define our input systems and our render systems. And that looks pretty good to me. I can't think of anything that I'm missing. All right. Just flick through what we did here. We reorganized all of our common code into a load game function, like all the starting instantiation of the game world. So the client and server can use it. Eventually we'll change it so they communicate together, or the server tells the client what to load the game as. But for now, we'll do that. And then we removed, or then we're also generating the sprites and keybinds for the player. Then we wrapped all the systems into various arrays for input, physics, and rendering. So that input and rendering could be on the client only, and we start them with a quit signal, so that they're quittable. Then in the server, we just added all of the basic stuff, all the runtime things that exist in memory, but don't actually interact with windowing systems, like input or rendering. Then we set it to quit at the end. Then we defined a new system file, system.go, which has a system struct, which can be run. It has a signal struct, which is thread safe. And it has a run game function. The run game function just executes all three of our system types and tracks the frame time. Then we have our physics updates where we move the transform component and the input component. We moved those in there, and we also wrote the handle input function, which takes the input specified and modifies the transform component based off of that. Then we have the render package where we added, I think this is a sprite file. Yes, in sprite file, we added the sprite component and the keybinds component. And then we have a draw sprites function, which draws all the sprites. A capture input, which captures user input and translates it to the input struct. I guess maybe a better name for that's capture keybinds, because input is the input component's like the output of this, but we'll leave that for now. Then we have our load game, which is our common game loading function. Eventually this will be much more complicated, but for now we'll just have it in a function. Then we have a function to create our physics systems, and the physics systems will be shared. I guess eventually the server might have extra systems here, and the client might have extra systems here, so we have to differentiate a server and client systems that exist for physics. And that's good enough. We'll call this, what are we on? We'll call this episode 11. Am I on the right branch? Yes, I am. What did we do here? We refactored. Refactor common code for client and server. That seems good enough. Okay, our dev branch. Looking good.